Okay, so next we continue with phase current, which is IR. Okay, IR, IY and IB. Okay, so for delta, for Y, okay, if we can refer this diagram, okay, at load side, so remember this is source and then this is load. Okay, the load side, the connection is Y. So we know that for Y connection, okay, the current will be similar for line and for phase. Okay, if we can refer for this diagram, so the similar current from line will be flow at phase. Okay, phase current. Okay, it will flow through Z, our impedance. Okay, so remember the equation for I equals to V phase divided by Z. Okay, Z per phase. Okay, Z phase lah. Okay, so for IR, the V phase is of course VRN. Okay, VRN, okay, divided by Z phase. Okay, so from previous question, okay, VRN is 230.9 angle of 0 degree divided by Z phase. Okay, 20 plus J35. Okay, same goes with this one, IY V phase. Okay, IY V phase divided by Z phase. Okay, so for IY, okay, VYN lah, VYN divided by Z phase. So VYN is 230.9 angle of 250 40 divided by 20 plus J5 J35. And then for IB, VBN, okay, divided by Z single phase. Okay, so VBN is 230.9 divided by 20 plus J5. Okay, so the angle for VBN is 0 degree kan. Okay, sorry, for VBN is 120 degree. Okay, so the answer for I phase is, okay, so for IR, okay, equals to, okay, 5.73, okay, 5.73 angle of negative 60.26. Okay, and then for this one is 5.73, this one is also 5.73. So in terms of magnitude will be similar. Okay, same goes untuk voltage and current. Okay, and then the difference is between angle. Okay, so this is 179.74, this is 59.74. Okay, you can use calculator to calculate this value. Okay, so since this the connection is Y, so the phase current, okay, the phase current will be similar with line current. So I phase equals to I line. Okay, so let's continue on example 6. Okay, so we have a 3-phase delta connected generator, okay, supplying the balanced load as shown in figure below. Okay, so it's mentioned that the generator is in delta connection and each of the phase current is 10 ampere in magnitude. Okay, the phase sequence is RYB. So this one is mentioned that RYB because of the question lets us to know that this is a balance or positive sequence. Okay, determine the following at load. Okay, so usually the question will be asked at the load side, okay, instead of okay, on generator side. Okay, it always given in the question, and what we need to find is at the load side. Okay, so the polar expression of each phase current. Okay, the polar is in terms of magnitude and angle. So the question asks to find phase current and line current, okay, for each phase. Okay, so for each phase we have 3 phase. Okay, so the given is IBR. So IBR, okay, IBR, and also we have IYB and IRY. Okay, practice write in this sequence. Say similar with the voltage, okay, the example 5. Okay, I start with VRY, VYB and VBR. Okay, and then VRN, VYN and VBN. See, same goes with current IRY, IYB and IBR. Okay, start on this sequence. So given is IBR 10 in magnitude, okay, and then the angle is 30 degree. Okay, so we know that, okay, the difference between these three current is in term of angle. So the magnitude is similar, 10 10. So the difference just in term of angle. Once again, if from the bottom you have to, okay, plus 120. So the angle is, okay, 150 degree, and then plus another 120. So the angle is, okay, 270. Okay, 270 degree. So this is I phase. Okay, I phase. If we can, okay, refer this diagram, I phase is IRY, okay, IRY, IBR and IYB, and then the line current is IR, IY and IB. Okay, so why we call this is IRY? Because it is flow from R to Y, IRY. And then for IYB is flows from point Y to B. This is point B. And then IBR flows from B to R. So that's why this is IRY, IYB and IBR. And then for this one, okay, at line, okay, the current is IR because it flow on R line. And then this one is IY flows at Y line, and then this is IB flow as B line. Okay, so this is phase, phase current. This is phase current. Okay, so the next question, okay, the polar expression for each line current. Okay, so this is line current. So we know that the relationship, okay, between phase and current is I line, okay, square root of 3 I phase theta minus 30 degree. Okay, so meaning that, okay, line current is higher, is square root 3 higher than I phase. Okay, the magnitude is higher than I phase. Same goes untuk okay, for Y. Y each line voltage is higher than phase voltage. Okay, line voltage is usually higher than phase voltage. Okay, by multiply square root of 3. Okay, right. So if we multiply by square root of 3, okay, okay, so this is IR. You can, okay, write it first, IR, IY and IB. So in term of magnitude will be similar. Square root of 3 multiplied by 10, okay, which is equals to 17.32. So this one pun 17.32, 17.32. Okay, just the difference is in term of angle. So the angle is theta minus 30. So IR, the partner is IRY. Okay, so the theta is 270. So 270 minus 30. So we can, okay, the answer is 240 degree. Okay, so if you refer the slide, okay, the answer is negative 120 because of, as I mentioned earlier, so this is 0 degree. If we read on the from the anti-clockwise, so this is 90, this is 180, this is 270, this is 360. If we read on the clockwise, so this is negative 90, so this is negative 90, so negative 180, and then this is negative 270. Okay, negative 270 is 3 and 60. Okay, so 240 equals to negative 120. This one, so this is 240. 240 if we read from the anti-clockwise. Okay, from the clockwise, it will become negative 120. Okay, so next IY. Okay, IY. Okay, the angle is 150. Okay, 150 minus with 30. So the answer is 120. And then for this one, okay, IBR, the angle is 30 degree minus 30. So the angle is 0 degree. Right, thank you.